Alright, so you're working on warm-up number 61. And number 1 reads, simplify and round your answer to the nearest tenth, and they give you square root of 10. See how you do with that. Number 2, it says graph f of x equals x squared without a table. Then write the rule and graph transformation if g of x equals a f of 1 over bx minus h plus k. And the parameters given is a equals -1, b equals 1, h equals 3, k equals 4. From there, factor completely for part 3. 3a, it says 3x squared minus 6x minus 45. For part b, it's 2x squared plus 7x plus 3. Number 4, it says divide the polynomials by synthetic division. And they give us p of x equals 7x cubed minus 6x plus 9 divided by x minus 2. And number 5 says graph. Part A is y equals -4, and part B x equals -2. Give you a little bit more time for that, yes? Okay. Copy and go. Alright, let's see where we're at. I see a lot of you, you're like, we got this, Mr. Q. Okay, good. You're right. Woo, let's go. So, square root of 10. The number 10 is in between two perfect square numbers. What are those numbers? 9 and 16. So what does that mean, Mr. Q? Yeah, so what I mean is that if we take away the square root, 10 is found between those two numbers. And you're like, why between those two numbers, Mr. Q? They have to be perfect squares in order to take the square root of them. Because now we can take the square root of 9, take the square root of 16. Anything in between is going to be a decimal. So square root of 9 is what? 3. Square root of 16 is 4. That means square root of 10 has to be between 3 and, that's why it's approximately 3 point something. So let's find that something. How do we find the square root of 10? So it's 3 point something. So I'm going to take this number from the small and I'm going to subtract it. This one from the small, I'm going to subtract it. And then I'm going to divide. So 1 divided by 7. So 1 divided by 7 does not fit, add a 0. Fits in there one time, that's 7. Subtract, that's 3. Add another 0. Fits in there 4 times, that's 28. I'll stop right there. So this is 3.14, but they want it to the nearest what? 10. So this is approximately 3.1. Hands if you got that. Okay, not bad, not bad. Number 2, without a table, graph f of x equals x squared. Now the reason I'm bringing these back again, I got kind of like confused myself on the final. I gave you one almost exactly like this one, and I said graph f of x equals x squared. By now, everybody should know that if it's a quadratic like so, it's a parabola that looks like this. It's a happy face. And it has to go through the point of origin 0, 0. Some of you in the final, this was given and you gave me a straight line. Now, what does that tell me? That you can't distinguish from a straight line to a quadratic to a cubic. So you need to start thinking in those terms. So, before I do my rule, let's look at what this is going to do to the original function. K, we know it moves it up and down, so since it's a positive 4, it's going to go what? Up. H moves it from left to right or right to left, but since it's a positive 3, it's going to move it to the right. B equals 1. What does that do to it? It either stretches or shrinks it, but since it's 1, let's see, what is 1 over 1? 1, so it's not going to do anything. It's going to stay the same for B. However, this -1 goes right here. What does that do to the entire function? Tell me, neighbor, what would that do to the entire function, that negative? Yeah, it's going to invert the function upside down. So let me show you how that looks. It's going to look like that so far. Okay? So now that we have that, what is the last thing we're going to do? 3 to the right and 4 up. Or my new vertex is going to be 3, 4. That means instead of 0, 0, I'm going to be up here at 3, 4. 3, 4. And my parabola is going to look something like that. That's my g of x. But they want us to write the rule, so let's see. I already substituted -1 here. H is 3, K is 4, so I'm going to write g of x equals -1 f of x minus 3. And this is a what? Quadratic plus 4. Hands if you got that by yourself? Okay, good. Yeah. Alright, go to number 3. Factoring. Factor completely. Look at this one. Is it in standard form? From highest to lowest degree? Yes. Is there a GCF? Yeah, it can be divided by 3 all the way through. So that leaves us with x squared minus 2x minus 15. Can I factor that trinomial inside of the parentheses? Yes. -15 and -2. So what two numbers multiply give me -15 that when you combine them give us -2? 3 and -5. 3 times -5 is -15. 3 minus 5 is -2. So now I just go over here and I write x plus 3. And for this one is x minus 5. But then don't forget to bring the BFF, which is that 3 that we took out at the beginning. There it is. And if you got that by yourself, okay, some of us, yeah. Part B. 2x squared plus 7x plus 3. Is it a standard form? Yes. Is there a GCF? No. So that means we go straight to our parts. Can you remember what number are we going to write on top? All right. What number, Brooke? 6. That is correct, because 2 times 3 is 6. Yeah, we have a coefficient now. And then the 7 goes down here. So what two numbers multiply give me 6 that when you add them give us 7? 6 and 1. 6 times 1 is 6. 6 plus 1 is 7. However, look up. We can't use this shortcut here because this one has a number here. This one didn't. You see how this one doesn't have a number? This one does. That means I'm going to rewrite this. 2x squared. Instead of 7x, I'm going to use these two as 6x plus 1x. Then I'm going to bring down the last term, which is plus 3. And now we're going to use factoring by grouping. Let's group the first two, the last two. So what is GCF for these two? It can be divided by 2 and by x. So it's 2x. We're left with x plus 3. Plus GCF for these two is 1, and we're left with x plus 3. So what's left over? What's the same? These two, that is x plus 3, that's one factor. And what was left over? 2x plus 1. Woo, let's go. Piece of cake, yeah? All right, yeah, I love these, Mr. Q. All right, good. All right, go to number 4. Synthetic division, let's go. And you're like, my favorite. Okay, let me make some space here. So it says divide the polynomial with synthetic division. They give us an equation on this side, but they give us the polynomial. So I'm just going to use the polynomial here. Okay? So here goes the process for those of you that forgot, especially since this one was on the final, right? Here goes the process. Step 1, identify the degree of each term. So what is the degree for this term? Degree is 3. There it is. How about this one? An invisible 1. How about this one? 0, because there's no variable. Okay. Is it in standard form from highest to lowest? Yes, but is there a missing degree? Yeah, a 2. I'm going to box it, put it in there, so like that I keep that in mind. How about this one? First degree, 0 degree, is it in order? Yes. Anything missing? No. Okay. What do I do next? I'm going to take this one, set it equal to 0. Solve. X equals 2. That one goes over here as my divisor. There it is. Next, for synthetic division, we don't need any variables, just coefficients and constants. So what is my first coefficient? 7. That's for the third degree. How about for the second degree? Do we have a second degree in here? So what do we write? 0. There it is. Next, for the first degree, what do we write? -6. And for a 0 degree, what do we write? 9. Okay. Bring down the 7 so we can begin our process, and here we go. 2 times 7, that's 14. It goes above the line on the next term. There it is. Combine those. What is 0 plus 14? That's 14. Let's do it again. 2 times 14, that is 28. Goes above the line. Combine those, that gives us what? 22. And last but not least, what is 2 times 22? Goes above the line, that's 44. Combine those, since there's no other term after that, this is going to be my remainder. What is combined? That's 53. Yes? Yes, Richard Q? All right, good. So, some of you on the final, you did up to right there perfect. I was like, yes. So no, what's the answer? You need to write your quotient, yeah? All right, so here it goes. We started off with an x cubed, is that correct? But once you do a division, this is no longer a cube, now it becomes a squared. And if this is in standard form, that means this is a what? 14x. That means this one is just a constant without a variable. Then at the end you add your remainder as a fraction. What was it? 53 over x minus 2. Woo, let's go. Is it coming back yet, some of you? You're like, oh, I need to go to bed. Oh, go to bed early, my goodness. You're like, but I work. So? Me too. Somewhere you're like, you don't understand, Mr. Q. Okay, fine. All right. And the last one, number 5. Go to number 5. Graph. They're straight lines. So first get your coordinate plane. Label this. This is my y. This is my x. And I'm going to graph the first one, which is this one, part A. Y equals -4. Okay, so where's y, -4? Here's my y-axis. -4 is down here somewhere. And there's a line going straight through that point. And there it is. Let's go to part B. X equals what? -2. So let's go to x -2. Here's x. -2 is about right there. So that means there's a straight line going through that point. There it is. We good? Yeah? You're like, whew, that was a lot of stuff, right? Yeah, welcome back. 2022, let's go. We got this. Got it? All right. All right, copy the agenda for today. Here we go. Our agenda for today, warm-up number 61, Parabolas. And tonight's home play is page 183, numbers 1 through 4. And I'm going to give you 2 more problems that are going to pop up on the screen in a little bit, numbers 5 and 6 only. So copy that, please. And just a reminder, FYI BTW, I'm going to, between today and tomorrow, I'm going to try and add a button to my Canvas homepage, and it's going to be a zoom button. Is it already there? Okay, so then I just need to add a time. I'm going to add a time for when I'm going to go live for those people that are, some of you that are going to be absent for whatever reason. Because as we came back from vacation, some people were not here, so that they don't fall behind. I'm thinking you guys are early risers, so maybe 9 o'clock in the morning, yeah? Will that work? Yeah? So you're like, no. How about, let's see. How about 11? Around there, yeah? 12? No, that's my lunch. 2? The last period? I don't know if the last period's going to work. Or maybe. I'll think about it. Yeah. Fine. All right. Copy the Nearpod code E9JHW. Just in case you fall behind on the notes, because we're going to go like this. Watch. That fast. We're going to go really fast. I'm telling you. So, yeah, we're back, baby. Let's go. Let's go. We got this. All right. So, what's next? Oh, yeah. Previous home plate. Those that were absent, I said that for the break, I had you guys derive the quadratic equation of a parabola, right? So if I was to ask you right now to get a blank sheet of paper, you would be able to write it out completely. Which I'm not going to do, but I'm saying you did your practice. However, one thing I do need from you, last night I gave you your final. It needs to be signed. So, take a picture of the signature, including, just the part where they signed. Go to Canvas, turn that in. From there, bring me your final. From there, go around and grab a graph paper from on top of the cart over there. You're going to need it for the lesson. Get a Cornell note ready, okay? And I'm going to leave the home play for tonight on the screen if you need to copy that. Copy and go. All right, so once again, the home play for tonight, page 183, numbers 1 through 4, and number 5 and 6 written on the screen with a focus of 0, -7, directrix y equals 7. And for number 6, focus at -3, 0, directrix at x equals 3. Some of you are like, oh, snap, Mr. Q. Oh, snap is right. Let's go. These are fun, by the way. These are pretty cool. Yeah, I like these. So, y'all ready? Here you go. Our objective for today, can write and graph a quadratic equation of a parabola. Write that down at the bottom left of your Cornell note. Oh, my bad. Sorry. Let it go. There it is. I can write and graph a quadratic equation of a parabola. I can write and graph a quadratic equation of a parabola. So, before we went to Christmas break, I can recall on a Wednesday, you guys took notes of this, or a pre-session very similar to this one, yeah? I'm like, oh yeah, Mr. Q, I got that. Okay, good. So, what are we doing today? We're writing and graphing. What is it? Quadratic equations of what? What is our main concept? Parabola. So in your prayer model, what are you going to write in the center? Parabola. Yes? So here we go. In your prayer model, parabola. Definition. What is a parabola? A parabola is the set of all points equidistant from a line, in parentheses in blue, I wrote directrix, and a point known as the focus. Once again, a parabola, we know what it looks like, right? It's a happy face, sad face, and so on and so forth. It's a curve. It's formed by the set of all points that are equidistant from a line and a point, known as a directrix and the focus. Example, here's a focus, my point. Here's the directrix, here's a straight line. So if I was to sketch points that are the same distance away from those two, from the focus and directrix, it makes a curve that looks like this. Copy that. Oh, and don't forget to put arrows at the end of the parabola. All right. So let's see. Here's my arrows at the end of the parabola to indicate it continues going. So according to the definition, it says the set of all points equidistant from the directrix and the focus. So this curve is formed by placing infinite amount of points that are the same distance from here and here. So watch. The first point that's obvious between these two, between the directrix and the focus, is right there, which means the distance from here to here is the same as the distance from here to there. And if I continue going, all these infinite points that you don't really see, but it makes that curve, they are the same distance. So what are you saying, Mr. Q? That if there's a point here, that is the same distance from there to there, than from there to there. You're like, oh, I can see it, Mr. Q. Yeah, because it forms kind of like a square. Do you guys see the square here? Same distance? Yes. Which means, obviously, if I continue going and I place a point over here, that means that distance is the same as that distance. That's what we call what? Equidistant. Equal distance. And so on and so forth. However, what is a parabola? The curve. This curve. That's why I did it in green, so you can see this in green. Okay. So, if that's a parabola, tell your neighbor a non-example. What would you write or what would you sketch? Non-example. All right. Non-example. Andy, go. Help him out, Sky. I'm sorry? Okay. Lewis. A straight line, yeah. That's not a parabola. It's a straight line. What's a parabola? This curve. Another non-example. Juliana? Square, okay. Another one. Carlos? Pentagon. Okay. I'll give you another one. How about a cubic function? Yeah? And one more that we covered already. How about a circle? Pretty good, huh? Pretty good? All that with math. Let's go. You make some shirts, yeah?
Yes.
So if these are not parabola, then this is, and if I was to ask you to submit that or put that on your Insta or Snap or Kick or WhatsApp or whatever it is you use, tell your neighbor a hashtag. Hashtag what? What makes a parabola a parabola? Hashtag what? Bam! Equidistant. Equidistant points. And of course, obviously, hashtag focus, and directrix. That pretty much covers it, yeah? Yes, thank you. All right, good. All right. So, now that we know what a parabola is, it's none of these. It's a curve that looks like this. Let's look at the equation. Before we went to break, look up, don't copy this. I gave you guys the standard form of an equation that looked like y equals ax squared or ax squared equals y. Don't copy that. You already have that. We've already been working with this. Today, I'm going to move certain things around to show you the different ways of writing that. However, to remind you of what you memorized and you practiced over the break, you should have learned this process, yes? You got correct? So if I was to ask you right now to give you a blank sheet of paper and you derive the quadratic equation, you get an A, right? Okay. I'm not going to ask you to do that, but this is what you should have done by yourself in practice, yeah? But notice at the end, after giving a sketch and doing distance formula for each of the distances and simplifying, we end up with this itty bitty, and by the way, does everybody see the heart? We end up with this equation, which is a quadratic equation. This equation is known as a vertical parabola. Don't copy this, pay attention. Have you been working with x squared? Yes, I've been giving you that on the warm-up so you can remember that it's a parabola. However, if I was to leave y by itself here, and I get rid of 4p, and then it would look like this. If I was to get rid of this 1/4 p and replace it with another variable, it would look like that. All those are vertical parabolas. What does the word vertical mean? That when we graph it, it's going to open either upward or downward, vertically. But what do we need to graph it? We need a directrix, a straight line, so that we can have the points equidistant from it. Now check this out. Look what I'm going to do with your noodle. Ready? Pay attention. Today we're covering vertical parabolas. But if we're covering vertical parabolas, that means we're also going to cover what other kind of parabola? Horizontal parabola. Now check this out. If vertical parabolas are x squared equals 4py, that means horizontal parabolas are what? Y squared equals 4px. What is the only thing I exchange? The variables. And if I manipulate that, it's going to look like that, and it's going to look like that, but it's a horizontal because now it's going to open sideways. But we also need a directrix, and that's going to be an x value. So, copy this, please. Vertical parabola in blue, horizontal parabola in red, so you can have that on your notes. I'll give you some time for that. Copy and go. All right. So, there's one thing that I want you to remember. Look up, please. Whenever you are thinking about a vertical parabola, you got to remember that the directrix is going to have a y value. It's y equal to a number. Oh, sorry. There you go. There you go. So once again, whenever we're thinking about vertical parabola, the directrix, when they give us a value, it's going to be y equal to a number, whatever that number may be. Whenever they're asking us to graph a horizontal, the directrix is going to be what? An x value. X value. Now, why am I highlighting this at this moment? Because tonight's home play, they're going to ask you to graph it. You need to know which equation to write. Either x squared equals 4py or y squared equals 4px. Once again, let me remind you once again, the two equations are x squared equals 4py or y squared equals 4px. For example, don't copy this. This is what it's going to look like. They're going to ask you to graph, and they're going to give you a focus, whatever that value may be. Then it's going to say with a directrix of whatever the equation they give you. Okay? The first thing you need to do, pay attention to this part when they're asking you to graph, is look at the directrix. So watch. Everybody ready? Here goes. If the directrix starts like this, x equals to -3. Okay, the value is what? X. So that means right away you need to write an equation according to what you see in the directrix. So since they give us x, right away I'm going to write 4px. Which means if it's an equation, what should go on the other side? Y squared. Mr. Hugh, what if it was y equals 5? Well, what would I write? 4py, and what goes on the other side? X squared. That's the way of thinking about it, which equation to write. All right? Let's try it. So let's say I asked you to graph, and they gave us x equals 2. Tell your neighbor what equation you would write for that one. All right, let's see. Lenny, what would you say? Brianna? All right, so what value do they give us for the directrix? X. So that means we write 4px, yes? That means on the other side is what? Y squared. Do another one. Don't copy this. You're just practicing right now with your noodle. Here it goes. So if I gave you y equals -2, tell your neighbor what equation would you write for that one? All right. Noor, go. X squared equals 4py. Hands if you got that. Yeah. So that's the very first thing you should know how to write. Because if you don't get that down, you're not going to know how to graph the parabola. All right? It's on your graph paper. Enough of that practice. Copy this one. Example number 1. It reads, doesn't matter which one, just get a graph in front of you and write this example. Write and graph the equation of the parabola passing through the point of origin and the focus 0, 2 and directrix y equals -2. Now, before you finish copying, look up. What is the first thing we're going to look at? Directrix. So if you look at the directrix, tell your neighbor what would be the equation you would write for this one in order to graph. Tell your neighbor, please. Raymond, go.
X squared equals 4py.
Hands, if you got that. That is correct. Copy that. I'll give you some time. All right. So now that we have our equation, let's begin by underlining in red our focus, and let's plot that point, 0, 2. Oh, sorry. 0, 2. There it is. Next, I'm going to switch to blue, and I'm going to graph my directrix. Y equals -2. Do we know how to graph that? Yeah, we practiced on the warm-up. So where's y -2? Y -2 is down here. And there's a straight line going through that point in blue. There it is. All right. So if we were to graph a parabola formed by those two, we know that the points are equidistant. Is that correct? So do you see the first point already that we can plot? What is that point? 0, 0. Yeah, that's in between those two, right in the middle. But we need more, Mr. Q, of course. So I would do x, y, and then I got -2, -1, 0, 0, since it's already there, 1, and 2. Okay? Now, before I substitute values into the equation, look up really quick. Fine, I have the x value, yes. I got the y value, which is the only one I don't have, the variable p. So this is what I'm going to do. Look up. I'm going to change this one to a red to remind me that I'm going to substitute what value in there? The focus. So that means I'm going to write right next to this, x squared equals 4 times p times y. And what is p now? P is 2. So, x squared equals 8y. And now I can substitute my values in there. What's my first value? -2. That goes in here. -2. What is -2 squared? That's 4 equals 8y. Divide by 8. Divide by 8. 4 eighths is what? 1/2 equals y. All right, let's do it again. I'm going to do parentheses squared equals 8y. And now what's my next value? My next value is -1. What is -1 squared? 1 equals 8y, divide by 8, divide by 8, 1/8 equals y. So that goes right here. Now, I only have to do that computation for 2 values. Why? Because it's a parabola, and it repeats on the other side. So tell you never, what would I write here for 1? Yeah, 1/8. How about for 2? 1/2, yes. All right, let's graph that. -2.5. -2 and 1/2 is about right there. -1 and 1/8, -1, 1/8. 0, 0, 1, 1/8, 2 and 1/2. And there's our parabola. Woo, let's go. Process. Here goes again. What's the first thing we did? Look at the directrix. From there we wrote our equation. From there we plotted our focus, our directrix, and our midpoint. From there I rewrote this equation using the focus for P. There it is. And then I created a table with -2, -1, 0, 1, 2 for the domain to find my y. Plot your points. There it is. From 1 to 5, I'll come to borrow you with these. 4, 5, yeah. We just need practice. Let's do one more. I know I'm going a little fast, but we need to finish up this next example. Here we go. Go to the next graph. Copy this one. You don't have to copy all the instructions. Just write focus 5, 0 and directrix x equals -5. Focus 5, 0, directrix -5. So, by looking at this directrix, tell your neighbor, what equation are you going to write in order to graph this one? All right, Brisa, what equation? Y squared equals 4px. Hands, have you got that? That is correct. Let's plot our focus. Focus is 5, 0. 5, 0 is over here. Directrix is x equals -5. Right there. There's a line going straight through there. And what's the midpoint between those two? Again, 0, 0. Next, I'm going to rewrite this. Y squared equals to 4 times p times x. But instead of p, what am I going to write in there? The focus, which is what? 5. So we end up with y squared equals 20x. Now we need a table. X, y. Look up really quick. Just to finish up, look up. Look at the previous example. We had what? X squared, and we needed x values to substitute in there. But look at this one now. What do we have now? Y squared. Hold on. So what values do I need? Y, -2, -1, 0, 0, 1, 2. And same process. Parentheses squared equals 20x. Substitute -2. That's 4 equals 20x. Divide by 20. That's 1/5 equals x. One more. -1. That's 1 equals 20x. 1/20th equals x. Good one, guys. Did your home play? See you guys tomorrow. Bye. 1/20, and it repeats. This one is 1/20th. This one is 1/5. And let's plot it. 1/5 equals -2. 1/5 of x equals -2. 1/20th of x equals -1. 0, 0. 1, 1/20th, and 1, and, I'm sorry, 1/20th, 1, and 1/5, 2. There it is. Bye, guys. Have a good one. Enjoy your home plate.